We're now going to work on parsing the command line. Parsing the command line means we're going to read the separate strings and learn how to work with those strings. In our particular example, we want to convert the strings to integers, right? We're going to see that we read everything as characters, and we'll learn how to use a function called ASCII to int to convert those to characters. But let's first just go back and review command line arguments. All right, I'm going to pop up code blocks here. All right, what we're going to do is we're simply just going to print out the command line arguments. So we've now seen, right, we were working with a main that looked like this. When we'd write a C program, we'd have a very simple form like this, and main had no arguments here. But now we've learned that we can pass arguments then to main, and those two arguments are an int parameter named argc, which is an argument count, and then a char star star parameter argv, which is a two-dimensional array of strings. You'll also see it written as char star argv like that as a 2D array, right? And we can then work with that to go ahead and print out, we could say things. Well, let's just print out the argument count, right? So let's print out then argument count, and that's an integer. All right, argc, and let's print out, we know that by default one argument is passed here, so argument vector 0, right, will be a string, and that's argv at index 0. We know by default one argument is always passed to main, which is the name of our executable. Let's put this on a new line all by itself. Let's maybe use puts and generate a couple of blank lines before a program starts running. All right, and let's build this. All right. It took just a second here. All right, let's make this, make this wider. It actually wrapped. All right, so the first thing, argument count, right? Our argument count is 1. One argument is passed to main by default, and that's the name of my executable. And what I did was I made a code blocks project on my desktop. And so if we were to just pop open that desktop here, let's just go ahead and take a look at this folder. I made a folder called Parse command line for code blocks. Within that folder, here's our example 1 program we're working it with. When we said build and run, it made this file called bin for binary. I'm in the debug environment, so it made this, and it made this executable, Parse command line. So this path that we see here, then on my computer is users Diane desktop, Parse command line is the name of that folder, bin debug. See, we can see we went in there, and parse command line.exe. So when we say run, that's the name of the executable that we're actually running. Right? That's why that popped up there when we printed out then the argument vector. Right? So we said by default we got the one argument, right? That's what argc says, the number of arguments to count, and then we popped up the first, or the only one we got there. All right, now if we want to pass multiple arguments, right, as part of our review using code blocks, what we can do now is let's go ahead and write a loop and say for I equals 0, right, as long as I is less than argc, the argument count. Let's go ahead and print all of the arguments. And we'll change this just a little bit, change this up. Instead of argv at index 0, argv at index I. And let's do this. We'll print I and argv at index I. And if we just have the one argument, so if we build and run, sorry, I need to stop this from running. If we now build and run again, we'll get the same results. Right, same results. But now we can have multiple arguments in here. So with code blocks, if we want to pass some other arguments on the command line, we go to Project, Set Programs Arguments. Here we'll pass then some other information. Right, I'll pass 1, 2, 3, hello. Right, 2 other arguments here. All right. Remember, they're separated then by white space. So we can see our argument count then was 3. If we go back here, right, under Project, Set Project Arguments, notice I typed 1, 2, 3, space, hello. So there's 2 additional arguments I'm passing. One is the string 1, 2, 3. There's our string 1, 2, 3. And then the argument vector 2, which is hello, a string of characters, right? And we could pass individual characters, right? I can pass A space B space C, right? So you can have a single character in a string as well. If we run this, I don't have to rebuild when I pass new arguments, right? I'm using the same executable, right? We run this, I see that we see now we have 6 arguments, right, in the count, and we pass these single strings, right? So that was a refresher then on how to pass these. But these are strings, right? These are character arrays here. I can't go ahead and use this in a calculation. Let's just take a look at, I'm going to change these arguments, right? We know that I'm going to delete those, and I'm just going to leave 1, 2, 3 here, right? If we want that to be the number 123, right, what if I wanted to say something like, what if I were to find some variable, let's call it number, right? And what if I were to try and say, well, the number, go ahead and assign number argv, well, I know that's argv at index 1, right? If I try to build this, so if I compile, right, we're going to then get a warning. Assignment makes integer from pointer without a cast, right? So I can't go ahead and just assign this string of characters to an integer, right? That's illegal because this is a string of characters or a character array, right? argv at index 1 is actually a character array, and number is an integer. So I want to be able to convert those to numbers. In order to do that, I'll use a function called ASCII to int. Right? I could manually do this. Right? Let's take a look at what's inside argv at index 1. So let's then use in here, as we walk through here, let's not do it for 0. Let's just go ahead and say here, actually, let's just change this to 1. Right, our argument count should be 2. Let's just build and run. Right, our argument counts 2. The first name is the executable. The second thing is the string 1, 2, 3. All right, so we know then we have these 2 arguments. Right. So if in here I were to say for int, actually, let's just go ahead and print out the string length. So print the length of argv at index 1 will be, all right, so the string length, all right, is going to return an integer, actually a size underscore t, and so now I'll call the function string length, right, argv at index I, to see the length of that string, and I need the string library in order to use string length function. All right, no warnings. All right, and sorry, I forgot to include I there to substitute in here. Actually, to rebuild and run. All right, so my argument count's still 2, right? That's argc. That's what we're printing out here. Argument vector, there's my string. The length of that is 3. I could then convert that to a number. Right, let's stop printing out our argument count here. Let's comment this out. Let's just go ahead and in this case, let's insist then that we have at least one argument. We're going to say if our argument count, so if argc is less than 2, right, we're going to print out some sort of message. Say usage, usually we tell must have at least 2 command line arguments. And then we'll just go ahead and end our program here. All right. And now, so let's just change this. Let's get, so back to project, set program arguments. Program arguments, I'm going to go ahead and get rid of that. So our only argument here, right, our argument count will be 1. Our only argument will be then the name of our executable, and we'll see that we get this message, right? We're telling the user the way you use this program usage, we have to have at least 2 command line arguments. If we don't get at least 2, our program terminates. So now down here, we know we have at least 2 arguments. So here, we know that argv at index 1 exists, right? And we're going to say if argv index 1 is a string of digits, convert the digits to an integer number, right? Example, right? Convert the string 1, 2, 3 to the number 123. All right, well, let's see how we can iterate through that string. What we want to do is let's just go ahead and get the length, right? So let's call this string length. And the string length of argv1, we call the string length function, right? Pass it argv1, and now we'll know we'll get the length. We can say for int I equals 0, I less than string length plus I. Let's just go ahead and print out all of the characters in there. So print, and so each individual character we use %C. And that is going to be argv at index 1, and then the character index there is I. Okay. If we do that, let's put our original puts back up here. So we have a couple of blank lines at the top. And I didn't reset the arguments, right? Go ahead and put our 123 back in here. And let's run. All right, and there's 123. Right, that came simply from printing this out character by character. Right here, we knew that argv1 exists. Remember, this is a 2D array. Right, so to get to the individual characters, when we use argv1 all by itself, we print out the string. Right, so treat argv1 as a string of characters. I'll review from other lecture examples. To do that, we can print out the string argv1. Right, we use %s, and we simply say argv1, and that then interprets this character array. In this case, is a string and prints it out. But now we'll say, let's print each character individually. Right. If we do that, we treat this as a 2D array. And let's go ahead and print each one on its own line so that we see that here. So build and run. Let's see, what did I do? Oh, forgot my semicolon. All right. So here, then this printf generated this line right here, string argv1 123. And then we printed each character individually. All right. Once again, to reinforce the idea that when a string is a 2D array of characters, right, in this case, argv1 is a 2D array of strings. And then if you treat that as a 2D array, when you do that, you get to the individual character here. Right? You can access the characters individually is what we did here. We want to use that idea to convert now this string to numbers. Right? Because let's go ahead and print out then the character, right? And then let's print out the decimal. So let's see how these are stored then in the ASCII table, the numbers 1, 2, and 3. And all right, so now you can see, right, the character 1 is stored as a decimal 49. The character 2 is stored as a decimal 50, right? 3 is a decimal 51. Well, what if we said, let's show the value of, right, the decimal minus 48. So let me bring that down so you can see it. So what we want to do now is we want to say, take argv at index 1, that character I, and subtract 48 from it. And let's build and run that. And I forgot to show that with a %d here. So notice now we get the numbers 1, 2, and 3. So here, this is the character. See right here, this is the character representation. Here's the decimal representation. Character representation 1, decimal representation 49. So if I subtract 48 from each one of these, that gives us the integer values of 1, 2, and 3. And that's the same. Right. In the ASCII table, these are all stored together in memory. Let's pop up the internet here. We'll look at it. Let's get a new tab. Yeah. The Zoom tool is getting in my way a bit. So ASCII table. Yeah, not Amazon. Here's the ASCII table. All right. So let's look at the numbers in the ASCII table. Notice the character 0 is the decimal 48. Right? The character 9 is 57. These are all stored contiguously or represented contiguously in the ASCII table. So we can subtract 48 from each one of these to actually get the numeric value, which is equivalent then to also subtracting. You think of it, it's like subtracting the character 0 from each one of these. If I subtract the character 0 right, which is the decimal equivalent of 48. If we do this, same thing, build and run, we get the same results. Right, we get then 1, 2, and 3 from that. And actually, yeah. All right. A lot of times this is clearer to people if we just say 48. So either one of these works, right? That gives us the numeric representation of the numbers 1, 2, and 3. But what we want to do is we want to build those numbers 1, 2, and 3 into an integer, right? So we saw how to get to the individual characters individually, right? That gave us that. But now let's build the number 123 from the characters 1, 2, 3. And actually, character should have individual quotes. For character constants, right. Well, if you think about it, right, in order to get the number 1, we said that we had to take basically the number 1 and subtract the 0 from it. And that gives us then, right, that result is the integer value 1. Right. And similarly, right, if we take 2 and we subtract a 0 from that, the result is the integer value 2. 3, and subtract the 0 from that, result is the integer value 3. Now to get 123, well that's, so 123, all right, that's 1 times 100 plus 2 times 10 plus 3. So we're going to have to then perform similar math in order to do that. Let's create a variable named sum. Let's say for int I equals 0, I less than, right? So we're still going to go through that string length, right? That entire string. And now we can say sum is equal to sum times 10 plus, right? Now I want to take argv, the index, so at index 1, that's the string 123. I want to take that first character, right? And I want to subtract from it my character value of 0. Let's see then what happens as we walk through this. All right, let's do a run to cursor here. All right, so what popped up is what we had before. We could see these individual character values. Now we've got this sum. All right, let's say next line, we can see that 0 is assigned to sum. Now we're going to just come in here, right, and let's show, so argv, the argument vector, index 1, that at index 0, right, that's our character 1, argv, index 1, and then index 1 there, that's our character 2. And then string argv1 at index position 2 is the character 3. So we step in here, we said I equal to 0. Right. Sum happens to be equal to 0. So sum times 10, 0 times 10 is going to give us 0. We're going to add on to it. Well, we're going to take that character value of 1, right? Subtract 0. So 49 minus 48 will give us a 1 in our sum. So now we can see sum is 1. Well, now we're going to access this second character, which will be a 2. So let's go down here to the next line. So now we take what's in sum, which is 1, we multiply it by 10. Right, 1 times 10 is going to give us 10. We're going to add on. We're going to convert the character 2 to the number 2. We're going to see we have the number 12 here. Right, now you can see in sum we have the number 12. Now we'll move on and process the third character. Right, so next line, sum is 12. 12 times 10 is going to give us 120. We're going to add on, then we're going to convert the character 3 to the number 3. We're going to get 123. Right? And now I will be no longer less than our string length of 3. So when we're done, sum will contain our numeric value. Right? We can see here, sum has the number 123. So the sum contains the integer value of the ASCII string, right? Go ahead and print out. Leave a couple spaces. Sum %t. All right. And build and run this. Right. There's our string, right? Those are ASCII characters, but we can see the sum's 123. Now, will this work for other positive integers, right? Let's go ahead and set the program arguments. Well, will it work for the number 1? We'll just run that. Yes, we get a sum of 1. All right, will it work for a 2-digit number? So let's just try 42. And we can run that. All right, notice I'm not rebuilding every time. My program's already built. I'm just passing different arguments on the command line. It works for 42. Right? Another argument. All right, longer number, 2,345. Okay, there. All right, let's run that. 2,345. All right, it will work. We can convert then many ASCII arguments. I mean, hit build and run to integers. All right. And run that, right? And that works as well too. All right, that's working for positive. Now, it won't work for, we haven't set it up to work for negative, right? Let's see if I just now said set program arguments, right? What if I made this negative 123? We know it works for positive, right? Let's do a run to cursor here. All right, so what popped up is now we see we had these characters, and the first character here is not a numeric digit, is it? It's a negative sign. We were just making the assumption that everything in here would be a numeric character. So now if we were to run through here like this, notice what's my sum going to get? Well, my sum is going to get a -3 because that's the value of the ASCII value of the negative sign after we convert it by subtracting the 48. So what we want to do here is we want to be a little more discriminating. We could say, sorry, here, we could say something like, if argv at index 1, I, right, if that is greater than or equal to the character of 0, and if it is less than or equal to a character of 9, go ahead and convert that. And if we were to build and run this, we get 123 or negative 123. Right? We haven't dealt with a negative sign, but we have dealt with the fact that we're processing a non-alphabetic character. So what you can get more complex. You can go ahead and write this. We could go ahead and take a look at the first character and say, well, if it's a negative sign, then we want to keep that in mind and say that our result is a negative result, right? But before we go to all that trouble and write that ourselves, which it isn't a bad exercise to do, right? I've written it before. You could work through writing it after you work through this. But for your homework, you're going to use a function called ASCII to int. Now that you have an idea of how to do this conversion, we can look at, let's see, this reference that I've given you in this PDF here. We're going to look at the ASCII to int function, right? So what ASCII to int is, it converts a string to an integer. So it parses the C string. Parsing means you're going to read through the string character by character. Anytime we say parsing, we read through a string of characters, right? We're going to interpret its content as an integral number, and it will return an integer value. The function first discards as many white space characters, right, as in is space, as necessary until the first non-white space character is found, right? So we could write a function that does that too. We could start looking at our string and discarding white space characters. Let's take it, right? So what we could do is, I'm going to create then a variable called start character, and I'm going to say for int I equals 0, I less than, well, I still want my string length. If argv index 1 and I, well, we're checking to see if that happens to be equal to white space is a blank. Let's pop open the ASCII chart, actually. Let's just go to is_space. Is_space is going to show us vertical tabs, spaces, horizontal tabs. So here's what is_space does. It checks to see if there's a blank space, a horizontal tab, a new line, a vertical tab, a form feed, or a carriage return, right? That's what we consider white space. And so this will tell you whether or not you have a white space character. Right, what it does then, let's see what it returns. It returns a value different from 0, true, if it's a white space character, right? And here's an example of how you can go through a string and use test this function. So whenever I learn some of these new functions, I'll actually run their code to make sure I understand how it's working. I've used this one before, so I understand how it works. We're going to throw it in our program. And instead of writing all this individually, we're just going to say, so if there's leading white space, so if is_space, right, we'll pass it argv index 1, this character, right? We'll then say, right, start character. So we want to skip over leading white space. So start character is equal to I. That's where we want to start actually at I+1, but we're going to say actually we want to skip over that. So we want to say if it's equals 0, right, meaning there's leading white space, or it's non-leading white space. We want to skip over it. We'll set the start character there, and then we want to break out of this loop. So let's try this. Let's see if in here. All right, so I'm going to put one space and then the number 123. And say okay. Let's run here. All right, so start character has garbage, and I probably need to fix that. I do need to fix that. Let's set start character equal to 0. Now let's do a run a cursor. Remember, we have the space in front of 123. All right, so let's step in here. All right, this should return true, right? True is a non-zero, so that's not. Actually, I think I should have had my morning caffeine. If indeed C is a white space character. Oh, okay. This skipped over my leading white space. This is why this is working. All right. I should have had my morning caffeine. So when I set the program arguments, when it reads in the string, it skipped over this leading white space character. Well, that was not fun, was it? Because we wanted to actually then capture that. In this case, we know that this said that first character wasn't leading white space. So it did then set my starting character equal to I, which is what I would now, then here, this new I want to set equal to start character, because that's my first non-white space character here. And if I run here, all right, start character in this case is 0, which is the same as before. We'll just walk all the way through this. All right, and we'll get our sum of 123. All right, so now our program does what A to I does, right? If we go back here to A to I, it skips over any leading white space. So it's going to discard as many white space characters as necessary until the first non-white space character is found. That's what we did here. We added this code to find the first non-white space character. Right? We went through this loop. We said non-white space, or white space returns anything that's non-zero. This is our first non-white space character here. And so that's where we set our starting index to then go through our string, right, to skip over that, to mimic then the same behavior as what's found here. A string can contain additional characters after those that form the integer number, which are ignored and have no effect on the behavior of this function, right? If the first sequence of non-white space characters is not valid, right, or if no such sequence exists because the string is empty or it contains only white space characters, it doesn't perform any conversion and 0 is returned, right? Otherwise, so we're going to pass it the string of characters. It's going to return the integer value, right? And so what we want to do, so on success, the function returns the converted integer value as an int, right? There's also then, if it's out of range of an int, right? If it's, so an int, if it's 32 bits, 64 bits, it has a maximum range. You could try stringed along if your number is longer than that. Right, our numbers will be shorter than that. Here's an example of how to use it, but what I've also given you then is an example that I want you to run. Okay. So let's then stop this from executing here. Now that you have an idea of how this works, what I want you to do is I gave you a program called A2I1. All right, we're going to take a look at that. So I'm going to remove this from the project. We're going to add this one into our project. All right, cleaning my workspace. So here's what I've given you. So let's go ahead and take a look then. Right, back at problem number 1. You're going to have two values passed to the main function from the command line, right? These values are going to be a number of rows and columns, and you're going to have to take these character values and convert them to strings, right? And I want you to write a C program that reads the command line arguments, converts the strings to integers, and displays the integer values for rows and columns, right? And this says you're going to need the A to I function to convert that, and I want you to run the example A to I1 to understand what the function returns for various input strings, right? And I've given you a link then to the that C++ website that we've been looking at. So in order to use this A to I, well, that's the other thing, we need to see what library that's in, and we can see up here A to I is in the standard library, right? So if we're using C++, we pound include C standard library. Because we're using C in our program, we pound include stdlib.h, right? So that we can use A to I. But what we're going to see here is we're going to pass A to I, right, the string 12. Now notice here my printf, this backslash, then double quote, will allow me to print the double quotes. But here's what we're passing. We're calling the A to I function. We're passing it the string of characters 1, 2, 3. Right. And we're going to see then that A to I is going to return the value, integer value 123, and we'll print that out there. When we pass it negative 123, or a negative, the character minus, followed by the character 1, character 2, character 3, we'll get negative 123, and then we'll see what happens when we pass it a non-numeric character. Right. So let's just go ahead and build and run this. Right. So you can see now, A to I 12 should be 123. Typo. Oh, sorry about that. All right, A to I 123 returns 123. A to I minus 123, we get minus 123. But if we then put in a non-numeric character, we just get the value of 0 back, right? So it's important to know that our string contains all integers. If we pass it something that doesn't contain an integer, right, let's change this to 1A23. So now if we build and run this, notice this will parse through the string. The 1 here is an integer character, so it can handle the 1. But as soon as it gets to the non-integer, it just returns whatever value it has. You need to be familiar with that behavior. What you need to understand from this is when you pass it a string that can be converted to an integer, for example, 123, negative 123, that will work. When you pass it something that has a non-digit character in there, right, a non-numeric character, it will only convert as much of the string as possible. So in order to ensure that it converts the whole string, you would need to make sure that all of these are digits or numeric characters in here. All right, but the purpose of this is for you to play around with this example of A to I and have an idea of how that works. Right. Not deal with my typos then. All right. All right. And once again, that leading string returned a value of 0. All right, that's how A to I works. Let's pop up now what you're supposed to do, right, in this practice problem. These practice problems will help you with homework. So 2 values are going to be passed to the main function from the command line. These values will be the number of rows and columns needed to create a 2D array. Assume that argv1 contains the value for rows and argv2 contains the value for columns. Right. Let's put this in our description here. Let's actually then write a new program, file new. I'll just call this practice 1. Make sure it's in our debug environment. All right. There's our comments. Actually, I probably should have picked that up too. Here are the things that we want to do. We're all going to do this within the context of main. All right, so int main, right, int argc, *** right? Remember, you can write it like that, or you can write it like that. Either way. All right, like this for this example, to get you familiar with the 2 different ways to write it. All right. So we're just going to assume that argv1 and argv2 exist. Let's go ahead and set the program arguments, make sure they exist. All right, let's say we want 4 rows, 5 columns. So 4 space 5. You could have multiple spaces in there. All right, so they're going to be passed to the command line, right? We're going to treat the first one, then argv1 contains the value for rows. So extract the number of rows from argv1. So I could say int rows equals, I'm going to call the ASCII to int function. Pass it argv1. Columns, I'm going to call ASCII to int. And then pass it argv index 2. That gives me rows and columns, assuming those are good values that it returns. So let's just go ahead and let's maybe print that out. And if we build and run this, well, I didn't include my libraries for printf, standard.io.h, standard library for ASCII to int. All right, so I'm including those. I was complaining about the fact that I'm not using argc, and I need to remove this old example from the environment so I don't have 2 mains. All right, so we get our rows and columns. Okay. Fairly simple after our long study of the fact that these are strings and they have to be converted then to numbers. Right. Making that assumption, then allowed us to simply perform this conversion. Right? I don't. All right. Now, what we have to realize is that our program should check to make sure these arguments do exist. Right. Next thing is, are they numeric? We might need to check that as well. But that was the gist then of this first example. I'm going to go get some caffeine before I make the video for part 2, so I perk up a bit. All right, hope you have the idea then. Right, the essence of this, then what you should take away is the fact that the arguments that come in from the command line, even though they appear to be numeric, that's all character data. You have to convert that character data to a numeric format, in this case ASCII to integer, then to work with those strings as numbers. Right, the next video then will then more quickly solve the problem number 2 in the practice problem.